Do you want to enjoy working with Git? Do you want to understand what is Git merge and what different kind of merges that you can do in Git? Do you feel afraid when you see merge conflicts and you don't know what you should do? If yes, then you are in the right place, because today we are going to talk about merging in Git. So let's get started. First, we need to talk about important concept, which is head. What is head? Head simply is a pointer to the current active branch. What does it mean? When working in Git, only one branch can be checked out at a time. And this branch, this active branch, is pointed by the head pointer. So basically, the head pointer is answering the question where I am now. Head branch. Head is simply a pointer to the current active branch. If you have a history with one commit and with the default branch master, so right now the current branch or the active branch is master. That's why the head pointer is pointing to that current active branch, which is master. And when you do another commit, C2, the master branch evolve and also the head evolve to point to that master. When you do another commit, the master branch evolve and the head always pointing to the current branch, which is master. You can see the head inside the .git directory. There is a file called head, and this head file basically is pointing to the current active branch. Branches are cheap to create or to destroy in Git. Branch is just a simple file with a total size 41 bytes, 40 characters representing the checksum that's generated by the SHA-1 algorithm for this branch, plus one new line. So it's super easy to create or to destroy a branch in Git. If you want to see the branches, open the .git directory and go to refs and then heads. Here you will see all the branches in that Git project. Right now we only have one branch, which is master here. If we created another branch, say feature A, by running the command git checkout -b feature A, right now we'll see another branch or another file here called feature A. And as you see, right now we saw the feature A, and now the current active branch is feature A. Notice that each branch has a size of 41 bytes. This is the master branch and this is the feature A branch. All of them are 41 bytes. Basically, it's 40 byte for the checksum for that branch and one extra byte for that new line. When you create a new branch, there is two things happening. First, there is a new branch pointing to the last commit is created. Second, the head pointer now is changed and now it's pointing to this new branch. So there is two things happening. New branch is generated and the head pointer now is pointing to this new branch. Switching branches. Imagine you have a history like that. C1, C2, C3, and the current active branch is master. That's why the head is pointing to that current branch. When you create a new branch by running the command git checkout -b and add the feature A branch, on that moment we created a new branch called feature A pointing to the last commit, which is C3. And now the current active branch is head. Notice that the head now is pointing to feature A, not master. And when you do another commit, C4 for example, the feature A will move because it's the current active branch and the head is pointing to it now. The same also when you do another commit, feature A is moving and the head branch is pointing to feature A because it's the current active branch. Notice that the master is still pointing to C3 because it did not evolve, because it was not the current active branch when we did C4 and C5. How to make git merge? If you want to merge some work from another branch to your branch, first you need to check out the branch that you want the work to be merged into it. So first you need to check out the right branch. Second, you run the command git merge and you add the branch that you want to merge the work from that branch to the branch you checked out. Merging. We use merge to integrate work from other branches in Git. To merge in Git, you have to follow the following steps. First, your working copy should be clean. Your working copy should be in state that's ready to be integrated or get integration from other branches. So basically, you have to finish everything before you merge. If you are not sure about some changes, you can stash it, but at the end, your working copy should be clean. Second, your local repository should be up to date, and you can get this by fetching the latest from remote to make sure that you have the latest version in your local repository. Third, you have to check out the branch that should receive the changes, as known as the receiving branch. Imagine you have a situation like this. You have a master branch and you want to integrate the work from a contact form branch, which contains some commits. First, you need to integrate from the contact form to the master branch. So the master branch here is the receiving branch, and you have to check out the receiving branch, and you can do that by hitting the command git checkout master. Last, you do git merge from the target branch. The target branch here is the contact form, and you can do the merge by running the command git merge and the target branch. Let's take a practical example to explain the steps. Imagine we have the current situation and we want to build a new feature called feature A. So basically we create a new feature by running the command git checkout -b feature A. Okay, right now we have a new branch, a new pointer called feature A, pointing to the same last commit that the previous branch master is pointing to, and we start building the feature, adding commit after commit, C4, C5, and as we build and add new commit, the feature A branch is always pointing to the last, and this is the last commit in feature A. Here we said that the feature is ready now to be merged. It's already tested and we added everything, so we decided now it's ready to be merged. Okay, first we need to ask ourselves, what is the receiving branch? Which branch should receive these changes? And we answer by master. Master should receive these changes. So basically we check out the master by running the command git checkout master. And basically on that moment, we will see that the current branch is master. That's why head is pointing to master. Then we run the command git merge feature A. Basically right now we will merge the changes from feature A into, which is the target branch, into master, which is the receiving branch, and this change will happen through something called fast forward merge. What we'll see now, that the master branch will the tip of the master branch will move forward into the last commit the feature A is pointing to. This is basically a simple example to explain the steps to do a merge. There are two ways of merge in Git. First is called fast forward merge. What does it mean? When you try to merge a commits from another branch to the current branch, if there is a direct connection between this branch and the current branch, this is called fast forward merge. What's happening in this kind of merge? Basically, if there is a direct connection between this branch and the current branch, Git simply moves the current branch to the last commit to the branch that you want to merge into, because there is no divergent work to merge together. So basically, this is the fast forward merge. Git simply moves the pointer forward to point to the last commit in the branch that you want to merge into. This is called fast forward merge. Let's focus more on this example on the fast forward merge. So this is the current situation. As we saw, we are building feature A and adding commits C4, C5, C6. And right now, we mentioned that the feature is ready and we want to integrate these three commits C4, C5, C6 into the master branch. So we checked out the master. What will happen here? Something called fast forward merge. Because there is a direct connection between the last commit in the receiving branch, which is master, and the last commit in the target branch, which is feature A, there is a direct connection between them. Then basically what Git will do, Git will move the master branch to the last commit for the target branch. Basically, it's moving the tip of the receiving branch forward to point to the last commit in the target branch. This is the fast forward merge. So basically, it's just moving the tip of the branch into the last commit. Imagine you create your own application and you want to create a new feature. Let's say it's called feature X. So basically, you check out master and you create a new branch called feature X. And you do some work and you do some commits on that branch, on the feature X branch. While doing that, you discovered a crash on the real production app that's really crashing. So you switch it quickly to the master branch and you created a new branch called hotfix, trying to fix this crash on the production. After doing some work on this hotfix branch, you already fixed the issue and you decided to merge this hotfix to the master branch. So this kind of merge, it's called fast forward because there is a direct connection between the branch that you want to merge into, which is master, and the branch that you want to merge in, which is hotfix. Meaning that you can reach the last commit in the master branch from the hotfix. So basically, this kind of merge, it's called fast forward merge. After merging that, you really fixed the issue in the production and you decided to switch to your old good branch feature X. Okay, after doing some work there, you decided that the feature now is ready to be merged to master. But wait, master now is not the old master. Master is containing the hotfix. So basically, this kind of merge, it's not called fast forward merge. It's called three-way merge. Why? Because there is no direct connection now between the branch that you want to merge into, which is master, and the branch that you want to merge in, which is feature X. Because right now, master diverged from the old master. Master now is containing the hotfix. So basically, Git decide that this kind of merge, it's called three-way merge. Why it's three-way merge and what are these three-way merges? Basically, these three ways, it's the last commit on the feature X and the last commit in the master branch and the common ancestor between these two branches. So basically, this is the three ways. Merging through the three-way merge creates a new commit called a merge commit. And this commit is a special commit because it has more than one parent. And these parents are the last commit from master and the last commit from the feature X. And this two commits, basically, when they are merged together, they create a new snapshot or a new commit called merge commit.
Three-way merge. Let's take this example to explain the three-way merge. So the current situation, we have master and we are building a feature A. So basically we create a new commit in feature A, C3, one more commit, C4, and as we see, the feature A branch is evolving because it's the active branch. While working on feature A, we discovered a crash in the production. On that moment, we need to leave anything and to fix this crash. So basically, we go to master by checking out master, and we create a new branch called hotfix to fix the crash that's happening to the people by running the command get checkout-b hotfix. Okay, this is the hotfix branch. We will start to fix the crash. Let's say it's C5 and then one more commit C6, and on that point we already fixed the crash after testing and we saw the crash is not happening anymore. So this is the commit that we want to merge, or this branch, the hotfix branch, now is ready to be merged. So basically we want to merge the hotfix into the master. So we check out the master by running the command get checkout master. After that, we will run the command get merge hotfix. As you see here, after running the get checkout master, we are on the master branch and the head is pointing to the master. We will do the merge by merging the hotfix into the master branch, and here what will happen, the merge will happen through the fast forward merge because there is no divergent. Basically, the last commit on the hotfix and the last commit in the master can be reached and they are connected. After that, we go to the old feature A branch. We check out this branch, and let's say suppose you have decided that this branch is complete and ready to be merged. Right now, as you see, the master diverged from the old master. There is no direct connection between feature A and master. Okay, we want to merge feature A into master. Then we check out master, get checkout master, and then we run the command get merge feature A. This merge will not be a fast forward merge because there is no connection or there is no direct connection between feature A and master anymore. This will happen through something called three-way merge. And these three ways are the last commit in the branch that we try to merge in, and the last commit in the branch that we want to merge into, and the common ancestor of these two branches. So basically the last commit in the master and the last commit in the feature A and the common ancestor between these two branches, which is C2. This will generate a new commit, and this commit is special. It's called a merge commit, and this commit has more than one parent. Let's take an example to explain the difference between fast forward merge and three-way merge. Right now, we are in our demo project on branch master, and we want to build the feature A. So basically, we get checkout, we create a new branch called feature A, and when we say get checkout -b, we create and check out the new branch. So right now the head is pointing to feature A. Let's do some work. For example, this file hello world that we have, let's say it's feature A, for example, and let's stage that, commit that, and we will say feature a first commit as a commit message. We will see later how to write a clear commit message, but this is just for testing now. So feature A now has this first commit. Let's do another work. Basically, we can create another file and name it feature A something. So this is another file. If we go to Git status, we will see that this file is untracked, this new file, by saying git add all and then git commit, and we will say this is second commit in feature A. So right now in feature A we have a history like this. We have feature A first commit and then second commit in feature A. Okay, we will say feature A now still in progress. So let's create another commit. For example, echo, instead of hello world, we will say this file is called feature A dot something, and we will add some new content there. Okay, this will be the third commit in feature A. Yeah, we need to add it first and then we need to commit it. Okay, so right now we have 3 commits in feature A. First commit, second commit, and third commit. The feature A is still in progress. And right now we discovered a crash in the production app. Then we have to leave anything. This is the highest priority now because this is crashing for people. So we need to create a hotfix immediately. So basically we check out the master. I have a shortcut for checkout. It's called GCO master, and I will do the same. I will create another branch. I will name it hotfix, and there I will imagine that I created the hotfix by, for example, let's say this file, this hello world file. Basically, this is the file that's creating the crash, and I will imagine that I created a fix fixing the crash. So this will fix the crash. Okay, right now the hotfix branch contain the fixing the crash. I need to stage this. I need to commit with a clear message fixing the crash. Okay, so right now on the hotfix branch we have a new only one commit and we can see the history. So this is the master and this is the hotfix, and the current branch now is head and it contains fixing to the crash. So basically right now I will say the hotfix now branch is ready to be merged and I want to merge it to master. So as we know the steps, we should check out master and we will say get merge and the branch name, which is hotfix. All right, so basically right now what happened is the master branch, this is fast forward merge. As we see here, this is called fast forward. Basically, because there is a direct connection between the target branch and the receiving branch, there is a direct connection between them, then the merge will happen by moving the master branch tip, which is the receiving branch, to forward to the target branch, which is hotfix. So basically this is just moving the tip of that pointer to be exactly like the same tip for that branch. So this is the fast forward merge. Okay, right now we didn't, if we say get branch and we say list dash dash list. Right now we have three branches, the master and the hotfix and feature A. Right now hotfix is already merged, so basically we can delete it by running the command git branch -d, and then we add the branch that we want to delete it, which is hotfix. Okay, so now the hotfix branch is deleted, and we will go back to our old branch, which is called feature A. So feature A now, if we checked out feature A and we see the history, okay, so feature A now, the head now is pointing to feature A, and basically the master branch diverged from the old master, right? Because that master contains the changes that came from the hotfix. So there is no direct connection now between feature A and master. That's why this, the new merge that will happen, we saw that we have three commits now. This is the commits that coming from the feature A. When we try to merge it to master, this kind of merge, it's called three-way merge. And right now we want to, for example, we want to integrate the feature A to master. So basically we check out the receiving branch, which is master. Let's merge feature A into master. First we will check out master, and then we run git merge feature A. Okay, right now we have something called conflict. Basically, conflict happens when two branches try to change the same line. Let's open Tower to see a better view for this. So right now we see that the changes that's coming from feature A branch, this change is fine, but here we will see there is two branches to try to change the same line. Let's open that file and we will see signs like this. This thing means that this is the changes that the current branch tries to write on that line. So basically master try to write this line here, fixing the crash, and feature A tries to run or to add this thing on that line. So basically we have more than one option to fix this. We can take the changes that's coming from feature A and delete the changes that's from the head, or the other way around, to take the changes from head and leave or drop the changes that's coming from feature A, or to take both or to drop both. And we can do it manually by removing this thing. So basically if we want to take the changes from head, we'll move the changes that's coming from feature A, and we will remove also that thing, and we will mark that file as resolved. Or we can take the other way around. But here the changes that's coming from the head, it says fixing the crash. So basically, of course, we want to keep that because we don't want to have another crash in the production. So basically we will take changes from two branches, and we can do it from Tower by saying take both. So basically this will say that we want to take both. Here this is only from feature A and this is only from head. So basically we will do it manually by opening here, and we will say, okay, I want to keep the fix for the crash, so I will keep it, that line, and also I want to integrate the feature A changes, so I will keep it like this. So I will save the file and go to the Tower, and I will go saying resolve merge conflict, and I will say mark this file as resolved. So right now when I say mark this file as resolved, I am telling that Git system that this now is this file now is resolved. And as we see here, this is the old changes that was in the master, and this is the new changes that's coming from feature A. And I will commit this. I will say this is merge branch feature A, and I will commit this. So right now, if I go there, I will see that now the changes that came from the feature A branch is already merged, and I can see that this is git log, and I will see now, right now, the head is pointing to master, and I will see there is some extra commit. This is the merge commit. So basically, I can go to tower again to get a better view, and we'll see here. This was the changes that's happened on the feature A. As you see here, this is the red line. This is feature A, and this blue line, it represents the master. So master, it has the first commit at the beginning, and then fixing the crash, that this is the commit that came from the hotfix branch. And here, this is the new commit, the merge commit. Basically, this merge commit contains three is a three-way merge. So this merge commit contains the last commit from the feature A branch and the last commit from fixing the crash, and basically this commit, which is the parent of these two branches. And this merge commit contains all this information. That was merging in Git. Thank you for watching, and see you in the next episode.